We're in section 1.4, rewriting equations and formulas. Okay, you need to know one definition, and that's a literal equation. A literal equation has two or more variables in the equation. So is this a literal equation? Does this equation have two or more variables? No. The only variable is x. Is this a literal equation? Yes, because it has two variables. You have two homework problems like this tonight, numbers 10 and 12. Please don't get to these questions and think, I have no idea how to do it. I just told you, okay? So go back and watch the YouTube video or go back and look in your notes. It's easy to forget a term that we're just learning for the first time. So go back and look in your notes. That's a pretty easy question to answer. All right, example 1, rewriting an equation. So I'm not solving anything. I actually cannot solve a literal equation unless I know at least one of the values of the variables, okay? So we're not worried about finding an answer. All we're trying to do is solve for whatever variable it's asking us to isolate. What does it mean for something to be isolated? Ethan? By itself, alone, okay? So we have the equation 2y plus 5x equals 6, and we are isolating y. We're solving for y. Okay, rewriting. All right, so 2y plus 5x equals 6. All right, if I need to solve for y, I follow the same process that I solved when I was solving for two-step equations. I need to first move the term that is not connected to the variable I'm solving for. All right, now I see a lot of people just in classwork trying to divide here. Now I understand what you're thinking. I'm multiplying 5 times x, so I need to divide. But what happens is you cancel this out, and the x is still left over there. So you're not actually moving the entire term, okay? So instead of doing that, what would you do to move 5x to the other side, Sarah? You would subtract it. How did you know to subtract? Because of the plus. The sign in front of the 5x tells me that it's positive. So that's how I know that I'm subtracting it. All right? Now, this is a very important question. Can I subtract these two terms from each other? No. They are not like terms. One is a number, the other one is a variable. Do not subtract them from each other. You must leave them separate. They are not like terms. So that's different from what we've solved in the previous sections. Okay? They are not like terms. Okay? Now I'm almost there, but I still don't have y by itself. Okay, so what's connecting 2 and y? Is it addition, subtraction, multiplication, or division? Multiplication. So what would I need to do across the board to get y by itself? Divide by 2. And because I couldn't combine 6 and negative 5x, I'm dividing each term by 2. How did I know by 2? Because that's the number that was connected to my variable. All right, now I'm going to simplify. Okay, well my 2's cancel and all I have left is y. Can I simplify 6 over 2? What's 6 divided by 2? 3. So I'm going to have a 3 now. Can I simplify negative 5 over 2 anymore aside from changing it to a mixed number, which I don't want to do? Can I simplify it anymore? No, I can't. So minus 5 over 2x. Okay, and that's how I rewrite it. My whole goal was to get y by itself on one side of the equation, to isolate it. That's what I did, and whatever is left on the other side would be correct, okay? So we're rewriting equations. This is really important for algebra. We're going to rewrite equations all year long. Anything that has to do with algebra, we have to make sure it's in slope-intercept form, function form. We'll learn more about that, I think, in chapters 4 and 5, if I remember correctly. I could be totally wrong, but we're going to learn about it later in the book. Okay, so any questions on this one before we do the next one? Any questions? Okay, now I want you to do the second one. 12 equals 6x plus 3y. I want you to at least get through the first step. So this is very similar to the one we just worked. All right, in that I'm solving for y. So I need to first move what's not connected to the variable that has the y, or the term that has the y, and then I solve. So try to do as much of this as you can. I'm just going to give you a few seconds to get ahead of me. What would be step one? What would be step one, Elizabeth?
You have to subtract 6x.
Yep, subtract 6x from both sides. Okay, Ethan, can I subtract 12 minus 6x? Very good. No, I can't because they're not like terms, so I'm just going to leave them separate. 12 minus 6x equals 3y. Anybody know what I'm going to do next? What am I going to do now? Sherelle? Very good. Divide everything by 3 in the whole equation. Now I have to divide each term by 3 because I couldn't combine anything on the left side. All right, so now I have, what's 12 divided by 3? Can I reduce that? 4. What's negative 6? You got to pay attention to that negative. What's negative 6 divided by 3?
2x.
Negative 2x. Very good. Equals y. All right? And guys, you've got to get this. This is the same exact equation. All I did was manipulate the values to isolate y. But if I were to plug in a value for x and y into one of these equations, the other one's going to match up the exact same way. I didn't change any values. All I did was isolate the variable it asked me to solve for. Okay? Okay, so in example 2, we're rewriting a formula. So now instead of it being an equation, it's a formula. We've learned a lot of these formulas, okay? The first one's on the board. What's the area of a rectangle? A equals base times height, okay? So you know that one. What about area of a triangle? Say it with me. A equals 1/2 base times height. What about parallelogram? A equals base times height, BH. What about a trapezoid? You guys remember trapezoids from last year? A equals 1/2 times base 1 plus base 2 times the height. Very good. Area of a circle. A equals pi r squared. So all of those are formulas. We learned simple interest last year. I equals PRT. These are formulas where, and you know, this is something that, you know, maybe a review for you, but you know, we can solve for different parts of the formula, right? Sometimes we solve for area, sometimes we solve for base, sometimes we solve for height. Well, you can actually rewrite the formulas so that you're isolating the variable on one side of the equation that you're solving for. For example, if you're given an equation and it asks you to solve for base, you can manipulate the formula so that b is by itself on one side, and then you plug your numbers into the other side. All right, so A equals BH. A equals BH. Okay, so it asked me to solve for the red variable. Which variable is red? B. Okay, I know that's maybe not quite as much of a contrast on the screen, but yes, we're solving for B. So now we have to figure out what operation is connected with my variable. Is it addition between B and H? Is it subtraction? Is it multiplication or division? Multiplication. So if I need to isolate B, what am I going to do to both sides? Am I going to, yes, divide by whatever's connected to it. In this case, H. H is connected to it, so I'm going to divide both sides by H. And now B equals, because it asked me to isolate B, A over H. Okay? This is helpful. Maybe the problem gives you area and the problem gives you height. Now you know you're dividing area divided by the height, okay, to get base. That just helps us understand some of the why. All right, look at the next one. I equals PRT. I equals PRT. Which variable's in red?
P.
P. What operation is connected to P? Multiplication. And because it's all multiplication, we can do everything in one step. I want you to figure out, what am I dividing by? What am I dividing both sides by to solve for P? Okay. If it's different operations, we have to do it in 2 steps. But because it's all multiplication, I'm going to need to divide by what? What will I be dividing by for I equals PRT to solve for P? Sarah? RT. I divide by whatever it takes to isolate P. Okay? So if RT cancels over here, and all I have left is P, what does P equal? I over RT. Okay, everybody agree that looks a little different? Okay, so it's going to take some getting used to, but we need to remember these are the same operations we've been using the entire chapter, okay? So there's nothing new about it. It's just we're looking at it from a different perspective. We're manipulating formulas now, okay? All right, I want to practice one. I'm going back to example 1 now. This is number 15 on page 29, but I'm going to write it up there. Okay, I want you to solve for y. Solve for y on number 15. So this is now the 3rd problem we're doing like this. This type of problem is on your quiz and test. Okay, so we're solving for y. Okay, so what do we do first? You guys, for the most part, everybody did this part correct. What do you do first? Subtract 4x. Because we're solving for y, we need to subtract 4x first. Can I do 6 minus 4x? No, so I'm just going to write it out. 6 minus 4x equals 9y. And now how do I solve for y? Divide everything by 9. Was that a little easier the 3rd time around? Okay, that's a new concept, all right? So it's going to take us a lot of practice to really get that. That's why we have a couple of these in our homework too. So 2/3, because I reduced 6/9, minus 4 over 9. I can't reduce that one anymore, equals y. And I want you to leave them fractions. Don't change them to decimals. Okay, it just makes it really difficult to grade. It doesn't mean that your answer's wrong if you made it a decimal, but I might accidentally overlook it or think it's wrong, so it's just important that we all just keep our answers as fractions. All right, okay, so let's move on now to example 3. In example 3, we're rewriting temperature, all right? So is everybody familiar with the fact that we have 2 ways of looking at temperature? One is Celsius, the other one's Fahrenheit. Is everybody familiar with that? Okay, so what's important is that I'm comparing both temperatures in the same degree form, right? I can't compare one in Celsius and the other one in Fahrenheit and figure out which one's bigger. So that's where the conversion comes into play. All right, well, this is the formula, C equals 5/9 times F minus 32. If I know the Fahrenheit, but I want to convert it to Celsius, okay? So what I need you to understand is whatever variable is isolated, that's what you're converting to. Does that make sense? So this is the formula to convert to Celsius. How do I know that this is the formula to convert to Celsius? Mason? Because the C is isolated. Did that make more sense the 2nd time around? This is the formula to convert a Fahrenheit to Celsius. So if I give you a problem that has Fahrenheit temperature and ask you to convert it to Celsius, this is the one you use because the C is isolated, all right? So what if I need you to convert to Fahrenheit? Well, if I need you to convert to Fahrenheit, I need the Fahrenheit version of this formula. That's what they're asking us to come up with. All right, and here's how I do it. I need to first get rid of the fraction that is connected to my parentheses because I cannot combine F minus 32. They are not like terms. So how can I get 5/9 to cancel out to the other side? Anybody know? How can I get 5/9 to cancel? Sarah?
Multiply by 9 over 5.
Very good. I need to multiply both sides by 9 over 5. What happens when I multiply 9 over 5 times C. What happens when I multiply 9 over 5 times C? What's it going to be? Just tell me. 9 over 5C. So that's why I wrote 9 over 5C. I just had a question about distributive property. You could have distributed this, okay? The problem comes into play when you multiply 5/9 times negative 32, then you end up with a really gigantic fraction, and then you still end up multiplying by the reciprocal. So now you've done one more step, as opposed to just multiplying by 9/5 both sides and getting rid of the fraction altogether. So it's just a little easier. If you do distributive, you can still get to the answer, but this is an easier route because now 9/5 is on the other side without having to deal with the really large fractions. All right, that was a really good question. Okay, so what happens? 9/5 times 5/9 totally cancels out. And what am I left with on the right side? What am I left with? F minus 32. So 9/5 C equals F minus 32. All right, I'm almost there, but F is still not isolated. How can I get F completely by itself? All right, how can I get F completely by itself? Lily? You do, very good. You add 32 to both sides. Okay, can I add 32 to 9/5 C? Because it has that variable, I cannot add it together because that's a term that has a variable and a number by itself. So here's my formula for Fahrenheit. I went through all that. Hey guys, good news. This formula never changes. And this formula never changes. So now you have it. If you need to convert to Fahrenheit, you use the F formula. If you need to convert to Celsius, you use the C formula. And I will give you these formulas for your quiz and your test. You will need them, but I'm going to give them to you. You don't have to have them memorized. Okay? Just star example 4. Example 4, you're going to see a very similar question on your quiz. Okay? The average room temperature is considered to be 70 degrees Fahrenheit. How many of you, your parents, keep your house around 70 degrees, you know, give or take a couple of degrees, right? Okay, 72, 74 maybe, because that's a comfortable room temperature. So that's where that comes from. The temperature outside is currently 23 degrees Celsius. Is the temperature outside greater than or less than room temperature, the typical room temperature? All right, so somebody tell me, why can't I just automatically say, well, duh, 70 is bigger than 23? Why can't I say that, Shemaya?
Because Celsius and Fahrenheit, Celsius looks lower than Fahrenheit.
Exactly. I mean, it looks like it's lower, but I can't really tell until I'm comparing the same units, okay? So here's the part where it's going to be up to you. Do you want to convert Celsius to Fahrenheit? Okay, so if you're solving for Fahrenheit, you use the F formula, or do you want to convert Fahrenheit to Celsius, and then you would use the C formula because you're moving it over to Celsius. My preference is to convert to Fahrenheit because that's what we read temperature in, like in America, but it doesn't matter as long as you're comparing the same. So if I want to convert Celsius to Fahrenheit, I use my F formula, my F equals formula. F equals 9/5 C plus 32. Do you see how I decided which formula to use? That's the most important part. Because I'm going Celsius to Fahrenheit, I need to use my F equals, because I need to know what 23 degrees Celsius is in Fahrenheit. F equals 9/5 times my Celsius temperature that I'm converting. What is the Celsius temperature that I'm converting? 23. Plus 32. Here's where it gets really easy. Punch it in your calculator. 9/5 times 23 plus 32, all at once. What did you get as Fahrenheit? F equals what?
73.4.
Very good. 73.4 degrees. So that is greater than room temperature. Barely, but it is greater. All right, that's a day to open the windows. right? 73 degrees outside. I'm opening my windows to my house and letting all that fresh air in. That's a beautiful summer day. Is that our temperature during the summer? No, what season do you think that's probably? Spring or fall-ish, like November, okay? You see how we just made a real quick conclusion based on that information? Did the problem say anything about what time of year it was? All right, where do you think in the country or in the world that would be a summer temperature? Where, Sarah? Okay, Germany, yeah, that's farther north, or like somewhere up north, like even Michigan. Michigan doesn't get super hot. Now, it does kind of get into the 90s, though, so you might even have to go farther north. All right, that's everything you need to know, guys, for section 1.4, and that's it for chapter 4.